Hello everyone, welcome to the certificate course on reasoning and quantitative techniques. In this video, we are going to discuss the quantitative aptitude topic probability. Probability plays a significant role in quantitative aptitude as it allows everyone to analyze and calculate the likelihood of an event occurring, making it a crucial tool for solving real world problems involving uncertainty, particularly in decision making scenarios such as some fields like finance, business, and statistics. So mastering probability concepts will improve performance in quantitative aptitude exams by enabling efficient problem solving with the use of permutation and combination. So probability, it is a measure of likelihood that an event will occur. Like what is the chance that an event will occur? So we can measure it using probability. So experiment means an operation which can produce some well-defined outcomes. Random experiment is any experiment that will result in two or more outcomes. Is called as random experiment. For example, when we toss a coin, we will have two outcomes, either head or tail. Or when you roll a dice, we will have six outcomes, like any of the numbers from 1, 2, 3, 4, 5, 6. Sample space, the set of all possible outcomes of a random experiment is called a sample space, and it is denoted by capital letter S. For example, when you toss a coin, the sample space will have the outcomes as H and T. Similarly, when two coins are tossed together, sample space will have HH, HT, TH and TT. So there are four outcomes. Event is any subset of a sample space is called as an event. Like when we toss two coins together, we can define an event as getting at least one hit. So the possible outcome favoring these events are either HH, HT or TH. Null event, or also known as impossible event, is an event which does not contain any outcome. It is usually denoted by pi. For example, getting a number greater than 6 when you throw a dice. It is a null event. Sure event, an event which will contain all the outcomes which is equal to the sample space. When you throw a die, getting a number less than 7. That means we can get all the number 1, 2, 3, 4, 5, 6, which is exactly same as the sample space. So that is a sure event. Exhaustive events, when the total number of possible outcome of an experiment, mutually exclusive event or also known as disjoint event, if two events cannot occur simultaneously in the random experiment. When you throw a die, getting an odd number and getting an even number, two different events, these are mutually exclusive event. We do not have any element which is common to both even as well as odd number. Equally likely event, if two or more events are said to be equally likely if they have equal chance of occurrence. Like when you toss a coin, both getting head and getting tail both have 50% of chance. Therefore, they are example of equally likely outcomes. Classical formula to find probability. If a random experiment has n outcomes and if there is an event with the m favorable outcomes, then the probability that the event A will occur, it is denoted by P of A, is given by P of A is equal to m divided by n. Number of favorable outcome to the event m, that is m, divided by total number of outcome in the sample space, that is denoted by small letter n. Probability of any event always lies between 0 and 1. So maximum value of the probability is always 1 and the minimum value of the probability is 0. Okay, let us solve some questions based on probability. First one, find the probability of getting a head in a throw of a coin. So when a coin is tossed, we get either head or a tail. So sample space will have only two outcomes. So number of sample space n is 2. Therefore, the probability of getting head. Now, if event A is getting head, it has only one outcome, that is H only. So number of favorable outcome is m is equal to 1. So probability is P of A is equal to m divided by n. So which is equal to m is 1 divided by sample space, that is 0.5. When 3 coins are tossed at a time, find the probability of getting exactly 3 tails, at least 2 tails, at most 2 tails. So when 3 coins are tossed, the possible outcomes in the sample space, there are 8 outcomes, okay, which is given here. So n will be 8, total number of outcome is 8. The first event is exactly 3 tail. The favorable outcomes for exactly 3 tail, there is only one outcome exactly 3 tail, that is TTT. So m is equal to 1. Therefore, the probability of A will be equal to, we have to write n of A divided by number of element in the sample space. This is n of A. So will be equal to 1 divided by 8. Now at least 2 tails. So at least 2 tails means either 2 tail or 3 tail. So we can have either HTT, THT, TTH, and 3 tail is TTT. So there are total 4 outcomes. Therefore, the probability of B will be n of B divided by total number of sample space. So n of B is 4 divided by 8. That will be 0.5. At most 2 tail, that means either no tail, okay, or 1 tail or 2 tail. So the possible outcomes are either no tail is HHH, and these two have 1 tail each, and these 3 will have 2 tails. So total possible outcome will be 7. So probability will be equal to 7 divided by 8. So n of C is 7 divided by total number of elements in the sample space is 8. So 7 by 8. An unbiased die is rolled. Find the probability of getting multiple of 3, getting the prime number. So for a rolling of dice, sample space n is equal to 6. A is multiple of 3. The possible outcomes are 3 and 6, and the number of outcome is 2. So the probability of A will be m divided by n, that is 2 divided by 6, and right 0.33. Getting a prime number, if B is getting a prime number, then the possible outcomes are 3 and 5. Again n is equal to 2 here. So probability of B, we have to write as probability of B here, equal to again 2 divided by 6, that is 0.33. A bag contains 5 green and 7 red balls. 2 balls are drawn. What is the probability that one is green and other is red? Now the sample space, the total number of balls is 5 green plus 7 red, that is 12 balls. We have to choose 2 balls out of 12. So the number of outcome in the sample space will be 12C2. So 12C2 will be 12 factorial divided by 12 minus 2 factorial is 10 factorial into 2 factorial. So that will have 12 into 11 into 10 factorial divided by 12 minus 2 factorial. Here 10 factorial, with this we have this 10 factorial and this 10 factorial will get cancelled. So we'll have 12 into 11 divided by 2, which is equal to 11 into 6, 66. Now let us define an event A as one is green and one is red. Choose one out of green ball and one out of red ball. We need to select both, so we have to multiply, that is There are 5 red ball, you have to choose one, so 5C1. 7 red ball, you have to choose one, 7C1. So that will be 5C1 is 5, 7C1 is 7. Number of favorable outcome for A is 35. Therefore, probability of A will be 35 divided by 66 equal to 0.53. A bag contains 6 white beads and 4 red beads. A bead is drawn at random. What is the probability that the bead drawn is white? Total bead number of beads, we have 6 white and 4 red, and you have to select only one bead at a random. So number of elements in the sample space will be 10 out of 1, 1 out of 10. So that is 10. Now let us define the event A as getting one white bead. So getting one white bead is 6C1, and there are no red bead, 4C0. That is 6 into 1 equal to 6. Therefore probability will be equal to 6 divided by 10, that is 0.6. A bag contains 5 red, 7 yellow and 8 marbles. 3 marbles are drawn from the bag. What is the probability that all 3 are red, all 3 are of same color, or they are of different color? Now there are total number of balls. We have 5 plus 7 plus 8, that is 20 marbles. We have to select only 3 at a time. So total number of outcome is 20C3. So 20C3 is 20 factorial divided by 17 factorial into 3 factorial. You can expand it as 20 into 19 into 18 into 17 factorial with the 17 factorial into 3 into 2 into 1. This 17 cancels. We have 20 into 19 into 18 divided by 6. That will be equal to 1140. Now let A denote all 3 are red and no yellow and no green. So you have to select only red marbles. There are total 5 red. So total number of possible outcome are 5C3. And we are not supposed to choose either yellow or green color. So 5C3 will be equal to 5 factorial divided by 3 factorial into 2 factorial equal to 5 into 4 divided by 2 into 3 factorial. So this is cancels. 20 by 2, 10. Now probability of A will be equal to favorable outcome is 10 divided by 1140. 0.0088. Let B denote all 3 are of same color. So this will be possible either all 3 are red or all 3 are yellow color or all 3 are green color. Now there are 5 red color. We have to choose 3 out of 5. So that is 5C3 ways. We have to choose 3 out of 7, 7C3 ways. 3 green color out of 8 color. So this will be equal to 5C3 is 5 factorial divided by 3 factorial into 2 factorial plus 7 factorial divided by 3 factorial into 4 factorial plus 8 factorial divided by 3 factorial into 5 factorial. So 5C3 will be 10. So 7C3 will be equal to, we have 7 into 6 into 5 divided by 6, that will be 35. So 8C5 will be 8 into 7 into 6 divided by 3 factorial, that will be 8 into 7, 56. So total M is equal to 101, 10 plus 35 plus 56. Okay. Now, therefore, probability of B will be equal to 101 divided by 1040 equal to 0.088. Okay, next we have, let's see, denotes all three are of different colors. So that means one red color, one yellow color, and one green color. So we have to choose 1 out of 5 into 7, 1 out of 7 into 1 out of 8. So 5C3, 5C1 into 7C1 into 8C1. So that will be equal to 5 into 7 into 8. 5 into 7 into 8, that is 280. Therefore, probability of C will be equal to 280 divided by 1140. So that is 0.2456. A bag has 15 tickets numbered from 1 to 15. Two tickets are drawn at random from the bag. Find the probability that both the drawn numbers are odd numbers or both are prime numbers. Now, we have to choose two tickets to be chosen out of 15 tickets. Therefore, number of elements in the sample space is 15C2. That will be equal to 15 factorial divided by 15 minus 2, 13 factorial into 2 factorial. That is 15 into 14 divided by, that is 15 sevens are 105. The total elements in the sample space is 105. What is the probability of getting both odd number of tickets? So we have out from 1 to 15, there are 8 odd numbers. So these are 1, 3, 5, 7, 9, 11, 13, 15. So you have to choose 2 odd numbers out of 8. So that is possible in 8C2 ways. So 8C2 will be equal to 8 factorial divided by 8 minus 2 is 6 factorial into 2 factorial. So that will be 8 into 7 divided by 2, 56 by 2, so 28. Therefore, probability of A will be equal to 28 divided by 105. That is equal to 0.2667. Similarly, probability of getting prime number. So let event B denotes getting prime numbers. So there are 1, 2, 3, 2, 3, 5, 7, 11, 3. Total 6 prime numbers. So probability of choosing 2 out of 6 will be equal to 6 factorial divided by 6 minus 2 is 4 factorial into 2 factorial. So that is 6 into 5 divided by 2. So that is 15. So probability of B will be equal to 15 divided by 105. That is equal to 0.1428. Next one. Two unbiased dice are rolled at a time. What is the probability of getting sum of two numbers less than 5, sum of two numbers more than 10? Okay. Now we have, and sum is equal to 9, sum is multiple of 5, sum is a perfect square. So when two dice are rolled at a time, so the number of elements in the sample space will be total 36 elements. So that is 6 into 6. So n of s, if we have number of elements in the sample space will be equal to 36. Okay, now first one is some number is less than 5. The possible outcomes, favorable outcomes are 1 1 because 1 plus 1 is 2, 1 2, 1 3, 2 1, 2 2, 3 1. There are total 6 outcomes. So probability of A will be equal to 6 divided by 36 or 1 divided by 6, 0.1667. Second one, B, sum should be more than 10. The favorable outcomes are 5 6, 6 5 and 6 6. So 5 plus 6 is 11, 6 plus 5 is 11, 6 plus 6 is 12, more than 10. So there are only 3 possible outcomes. Therefore, probability of A, B will be equal to 3 divided by 36. It is 1 by 12, 0.0833. Let's see if sum is equal to 9. The possible outcomes are 3 6, 6 3, 4 5, 5 4. So 4 outcomes. Therefore, probability of C will be equal to, we have to do 4 divided by 36 or 1 by 9, that is 0.1111. Okay, next we have event D. A sum is a multiple of 5. The possible multiple of 5 is 5, 10, 5 and 10. So the sum should be equal to either 5 or 10. The favorable outcome are 1, 4. Here the sum will be 5, 2, 3, 3, 2, 4, 1, 4, 6 is 10, 5, 5 is 10, 6, 4 is 10. So the favorable outcome there are 7. So probability of D will be equal to 7 divided by 36. That is equal to 0.1944. The event E is sum is a perfect square. So perfect square are we have 1, 4, 9 and 16 will be bigger number because the maximum sum will be only 12. So less than 12 we have only 3 perfect square, 1, 4, 1, 1, 4 and 9. So the favorable outcomes are, so it is not possible to get the sum as 1. So this element is not possible to get. So here we have 4, again 2 and 2, 4. We have 4. This is 9, 9, 9 and 9. So total we have 7 outcomes. Therefore probability of E will be 7 by 36. That is 0.1944. Okay, next, what is the probability of getting 53 Mondays in a leap year? So in a leap year, we know that there are 366 days. So when you divide 366 by 7, we get a multiple of 7 will be 364. Out of quotient is 52. We have 2 as a reminder. So that means exactly 52 weeks and plus 2 extra days. So here out of 52 weeks, we have each week as 1 Monday, so total 52 Mondays. So remaining extra 2 days. So these 2 days, it can be either like continuous days, so either Sunday, Monday, Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, or Saturday, Sunday. So 1, 2, 3. Total we have the remaining outcome. The possible outcomes are n is equal to 7. Out of these 7 outcomes, Sunday, Monday and Monday, Tuesday, only these 2 outcomes are favorable that you get 53rd Monday. Therefore, the probability is equal to 2 divided by 7, 2 out of 7. In a company, 5 men out of 20 are graduated. If 3 men are picked out of 20 at random, what is the probability that all are graduated? At least one graduates. So we have to, in order to find the sample space, okay, out of 20, we have to pick only 3 people. So that will be 20 factorial divided by 20 minus 3, 17 factorial into 3 factorial. That will be 20 into 19 into 18 divided by 3 into 6. So that is 1140 ways. So total possible outcome is 1120. So let A denote all are graduates. So there are total 5 people are graduates. We have to select all the 3 people from this 5. So that is possible in 5 factorial divided by 5 minus 3 is 2 factorial into 3 factorial. So that will be 5 into 4 divided by 2, 10 ways. So probability that all are graduate is equal to 10 divided by 1140. Now, in order to find at least one is graduated, first let us find what is the probability that none are graduated. Okay, no one is graduated. So there are 15 people who are not graduated. Out of 25 are graduated. There are 15 people who are not graduated. We have to pick 3 out of 15, which is equal to 15 factorial divided by 15 minus 3 is 12 factorial into 3 factorial. So that will be equal to 15 into 14 into 13 divided by 6. Total possible is 450. 455. Therefore, probability that at least one is graduated is equal to 1 minus probability of none is graduated. So that is equal to 1 minus probability of none graduated will be 455 divided by 1140, which is equal to 685 divided by 1140. It is 0.6.